Good morning. Today we're going to use implicit differentiation to find the derivative of this function. It's an implicitly defined function. X times y equals the cotangent of x times y. So in order to do this, we're going to use implicit differentiation. We're going to derive both sides. So we have x times y, that's a product, so we'll use the product rule. It's the first times the derivative of the second. Well, the derivative of y as a function of x is y prime, plus the derivative of the first function, which is 1, times the second function, which is just y. And then we'll take the derivative of the second function. Now, we take the derivative of the outermost function first with the chain rule. The derivative of the cotangent is the negative cosecant squared of xy. Now we take the derivative of the inside, which is xy, which is actually, you notice it's the same thing we got over here, so that's the first times the derivative of the second, which is y prime, plus the derivative of the first, which is 1, times the second, which is just y. Now I want to distribute this cosecant, because I want to continue to solve for y prime. So I'll have negative x y prime times the cosecant squared of xy minus y times the cosecant squared of xy. I'm going to get both my y prime terms on this side, on the left side, and my non-y terms on my right side. So I'm going to subtract y from both sides, add x y prime cosecant squared of xy to both sides. So I'll get x y prime plus x y prime cosecant squared of x y on the left, and I will get negative y cosecant squared of xy minus y on the right. Now I'll factor out a y prime here on the left, because this is the only place it is. So we have y prime times x plus x cosecant squared of x y equals negative y, and you know what, I'm going to factor out a negative from both of those, and I'll get y cosecant, actually I'm going to factor out, second guess, I'm going to go even one step further. I just like the way it looks. I'm going to factor out a negative y from both of those, so I'll get negative y times the cosecant squared of xy plus 1. Now to finish out solving for y prime, I'm going to divide both sides by x plus x cosecant squared of xy, and then I'm going to do something else. So y prime equals negative y times the cosecant squared of xy plus 1 divided by x plus x times the cosecant squared of xy. Now I'm going to factor out an x from the bottom term, and this makes this derivative much easier. So we get negative y, and the numerator is still the same, cosecant squared of xy plus 1 divided by, factoring out of x, 1 plus the cosecant squared of xy. And then I have 1 plus the cosecant squared of xy plus 1 over 1 plus the cosecant squared of xy. So those will actually just knock right out, and I'm left with y prime, and I apologize for the sloppiness of, well, I'll just put it like that, y prime equals negative y over x. Didn't that work out really nicely?